In this video, we're going to talk about pretty common sort of exam question, which is taking something like the part A that you can see here and using it in part B. So part A is quite a common one. The idea is that what we do is we take what's in the question, sorry, that's a minus 3 cos x, and we compare it to some form that's been given to us. So we have to compare this against the form of r sine with the addition rule. So how could we do that? There's lots of ways of writing it, but maybe something like this. So this is sine x cos alpha, isn't it? Sine x cos alpha. So I'm going to write this as cos alpha sine x, and you're going to see why in just a second. And then a minus, and this is the other pieces. So the r would still be there because it would be expanded out, and this would be sine alpha cos x. So why am I writing them like this? Well, it's because you can compare the sine x on both sides, and you can use this to make some equations. So the first equation, for example, is that 2 is equal to r cos alpha. Okay, and then you can do some comparing with the cos x as well, and you can make an equation from that, which is 3, not minus 3, but 3. 3 equals r sine alpha. This leads us to get tan alpha as 3 over 2. So alpha, what does alpha end up being from all of that? I get 0.983. Okay, and how do we do the r? Well, the easiest way in general, and you don't need to justify this with anything, is you just do Pythagoras with these numbers here. So this is just a 2 squared plus a 3 squared. And for your r value on this one, you will get root 13. So now that we know, and this is kind of the key bit really of this video, now that we know that this is equivalent to root 13 sine of x minus 0.983, the idea is that we're supposed to use this typically in the next part of the question. So a tide gauge records the sea level in meters at a harbour. The height above the chart at time t hours after midnight is given by this equation. So what are we supposed to notice? Well, we are supposed to notice that this 2 sine x minus 3 cos x is the same pretty much as this bit here. However, with a few changes. The 7 is new, okay, and our x has become well, it seems to be pi t over 6. So the first thing we want to do now is we want to rewrite this one in terms of what we did in part A. So the height equals 7. I'm going to add the 7 because that's a new bit just added on. And the 2 sine minus 3 cos, well, I know that all becomes root 13 sine of x. Okay, but the x has changed as well. So that's going to be pi t over 6. And then what else? It has a minus 0.983. Okay, so that's the first sort of thing that you typically have to do for a part B, is you have to end up writing something like this. And now maybe using it. So use your model and your answer to find the maximum. Well, what's the maximum? If you have 7 and you add on some kind of sine graph, well, a sine graph normally goes up to 1, doesn't it? But because of the root 13, this sine graph now goes up to root 13. This bit just changes sort of what happens in the x direction, yeah? So that's not really too important for the first part. So the height is just 7 plus root 13. That's the new maximum height. The new minimum height would be 7 minus root 13. Okay? find the time of this high tide, so it would be a bit clearer, it would say the same thing, the maximum, to the nearest minute. So how do we do that? Well, there's a few ways of doing it. So probably the most efficient way is as follows. The maximum is normally achieved when on a sine graph? Well, it's usually when t, in this case, would be equal to 90 degrees because it's a sine graph, or in the world of radians, it would be pi over 2. Okay, so what we can do is we can sort of solve using this value, but account for the fact that it might have shifted. So we can solve something as follows. We can solve pi over 2, because this is really effectively taking into account this bit already, and this bit and this bit. This is thinking about when does sine usually have its maximum. Well, the first time it would usually have its maximum is pi over 2. What we're going to do then is we're going to set it equal to all this bit here, because this takes into account the fact that it's sort of been shifted and stretched and all this sort of stuff. Okay? One word of caution I would give you with this, though, is sometimes because of the shifting, you might find that your answer doesn't actually come from this pi over 2. Sometimes it comes from sort of other parts normally. So sometimes it might be coming from minus 3 pi over 2, for example. Okay, so you do need to be a little bit wary of that. In this one, though, we're going to solve it, I believe, with just pi over 2, and then we'll just check it carefully. So if I now do pi over 2 plus 0.983, and then the goal is to get t on its own, right? So if I multiply by 6 and divide by pi, that will be effectively getting t on its own. And if I do all of that stuff there, what do I end up with for my answer? I end up with 4.878. Now, if I kind of press the button on your calculator with some commas and so on, it will actually change that into a time for you. And it should say that you get 4 hours. Okay, I believe it is 4 hours. And to the nearest minute, 53 minutes. Now, you often have to write this as a clock time, like 24-hour time. So find the time, yes. So what you would do at the end is you would write this sort of as follows. Okay, to make clear that it was 4:53 in the morning. You can even put AM there just to sort of be safe if you like. If you do get quite a large value with this, just something to be careful of, what you would then do is you would say, well, it might have come from a different value instead. It may have come from, minus 3 pi over 2, and you can just test that for yourself. You just put that there, okay? But pretty sure in this case that's going to give us a negative number, so we're not interested on this particular question. If this is a new technique and you're thinking, I'm not really sure about this and where this comes from, all I would say to you is, if you try sort of solving by doing this sort of road, which sometimes people do, so that would be sine of pi t over 6 minus 0.983. Well, what you'll end up doing is you'll go like this, and then you'll get 1, okay? 1 equals sine, of all this sort of stuff. Well, the first time that you do inverse sine, you'll just end up with pi over 2. Okay, so you will end up solving exactly the same equation as we've been doing here already, but it's a little bit quicker if you're able to jump in based on your understanding of a sine graph. Okay, so the main skills there, using the addition rules to sort of write something in part A, and then embed that into something in part B and solve it. A very, very, very common question, this one here. So I think we've got just one more version for you to take a look at. So as always, I encourage you to pause the video and have a go for yourself. So jumping ahead slightly, our R value that we get will be a little bit more awkward this time. So it's the equivalent of the root of 15.25, or however you want to write that. Cos and then x, and we've got beta instead of alpha, and this is 0.876, I believe. Then what are we meant to do? We're meant to notice that this part here is the same as this part. This is the new bit. There's a little bit more going on as well, because on this question, x, what is normally our x in our equation, has been replaced with quite a lot of stuff. It's been replaced with pi t over 20 minus pi over 4. So yes, all of that bit would be just the x, and then you would still need that beta album as well. So let's have a go at kind of writing the new embedded version. So it would be t equals the 120s there. Notice 3 sine x plus. Notice all the signs match, so I don't need to worry about any of that. It's going to be plus 15.25 cos. Now I'm leaving loads of space because x is really complicated now. X is in fact pi t over 20 minus pi over 4. And then I still need to put my minus 0.876 there as well. So all of that gives me my new equation. What would the maximum temperature be? Okay, well, this has changed the question slightly. I didn't want the question to be this hard. I'm not sure if that's actually going to be that much of a problem, but let's just ignore that one for the sake of the demonstration. So the highest temperature that you could get would be 120 plus root 15.25 again, because ultimately it's a cos graph, and cos graphs are limited to 1 and minus 1 multiplied by whatever the number is on the front. When does it achieve its maximum value? So that's a good question. Well, a cos graph usually is at its greatest value at 0. So when you're solving on here, you should look at 0. And if we're looking at more difficult answers, because it's been shifted a lot, we might have to perhaps have a look at these values. So we would be looking at 0 or minus 2 pi or 2 pi and so on. Okay, so how would we answer the rest of the question? Well, it would be something like this. So if we test 0 first, we'd be doing 0 is pi t over 20 minus pi over 4 minus 0.76. And yeah, you can get a hang of, in terms of which of these are at play, you can get a hang of that from the size of the translations. Minus pi over 4 is not that radical. It's not too much. That's a reasonable shift, but it's not enough to move something from minus 2 pi or 2 pi into being the value that we're interested in. So what could you do here? You could do 0.876 plus pi over 4. And then you could multiply by the reciprocal, which would be 20 over pi, and that would give you your t value on this one here. Okay, and I believe that gives you a value of 10.58. Now you've got to go back to the question. That 10.58 is in minutes. So if you kind of do, well, the 10 is 10 minutes. If you convert 0.58 minutes, you should find that this becomes 35 seconds to the nearest second. Okay, and it just says the time after. It's not asking for like an AM PM time. So that's it. That's all we would do. So look out for this next time that you're doing your practice questions. Part A embeds into a part B in the question that you have, and you can use your knowledge of sine and cos graphs to speed up the solving step somewhat.